So page 2 of our chapter 4 congruent triangles review. We'll begin with AB, segment AB parallel to segment CD. Okay, so again, what we're looking for is a Z or a backward Z. You're going to see if you trace BA down to C, then over to D, you're going to get angles 1 and 7 for alternate interior angles. Okay, for B, FB is parallel to ED. Again, that's going to be a backward Z. If you can look at that right there, backward Z. You're going to have alternate interior angles 4 and 9 for congruent to 9. Okay, so I had to erase things because really angle 1 congruent to angle 7 doesn't help us. So let's focus just on what's given for this proof. 5 is congruent to 11. That gives us one pair of corresponding angles congruent. That's an A. All right, AF congruent to EC. That's not quite a full side. We need all of AE the same as all of CF. So we're going to use addition. AF plus FE. That's going to be equal to CE plus EF. Then we're going to need that EF to be stated the same in both, which is reflexive property. So we'll have a couple of steps in here that will come up. So first I'm trying to show which pair of triangles we want to show are congruent. Okay, so it's these two, the one on the left, the one on the right. Okay, and I'm marking it based on the givens and what I can infer. So I can infer angles 4 and 9 congruent because of the parallel. I'm given 5 and 11, and I'm going to have to work for AE congruent to CF. But we're going to be able to get that. So it's going to be angle, side. All right, the first two are given. The reflexive is FE is in both triangles, but it's not quite a full side. So we got to do a little bit more. All right, this is number 4. It really should say, for number 3, it should say property right there. Reflexive property, but they gave it to us, so I left it. This is supposed to be segment addition postulate, number 4. There should be a step in between, but this is what was built for us, so we'll explain a little bit more. I'll come back to it right here. Yeah. So basically what I'm doing is I'm explaining that the AF plus FE is equal to in length of CE plus FE. Okay, then we go to the parallels is given. Angle 4 congruent to angle 9, alternate interior angles theorem. So I'm writing that out. And 7 is angle, side, triangle congruence theorem. All right, number 6 goes back to a proof, or I'm sorry, it's not a proof. It's something we worked on in the notes. If you look at this, it's a side-side angle. It's basically talking about why does side-side angle not quite prove triangles are congruent. It's not quite enough. What it will do with side-side angle, we'll end up being able to narrow it down to 2 possible triangles. The first one I'm showing is the congruent triangle. So that would be great. However, if you look at where C prime is right here, one location for C prime is right here. Now, if C prime's right there, it's congruent to the original, but C prime could also swing over to here, and we would still maintain this side-side angle, but it wouldn't be congruent triangles. So right there, you're noticing we still have these sides BC and B prime, C prime congruent, so it's side-side angle. It could produce a congruent triangle, but it might not. There's 2 possible triangles. So side-side angle is not enough. One's congruent, the other one is not, so we can't use it to prove. All right, that's it for page 2 of chapter 4.